Hello there, young students of chemistry. This is a quick recording about how to alter an equilibrium position. Many of the reactions that reach equilibrium are reactions that we want them to make products. So what we do is we apply this principle, LeChatlier's principle, in such a way as to get the products that we want. So LeChatlier's principle says, when a reaction that is at equilibrium is stressed, it will shift in such a way as to relieve the stress. So take a minute and write down that definition. And what does that really mean? So really what it's saying is that whatever we do to the equilibrium system, the reaction's going to do the opposite. So I think it's important when you look at these to consider, what did we do? How will the reaction respond? And which way does it have to shift to make that response? So here's the thing, we say that an equilibrium reaction will either shift left or shift right. When I say shift left, what I'm saying is that the reverse reaction is going to run. So we have the forward reaction and the reverse reaction. If the reaction is shifting to the left, the reverse reaction runs and the concentration of the reactants increases and the concentration of the products decreases. And if the reaction shifts to the right, the concentration of the reactants decreases, the concentration of the products increases. So that's what I mean by shifting left and shifting right. The forward or the reverse reaction will start running more strongly. So when I say stress, these are what I'm talking about. Stressing the equilibrium. One of the things we can do to stress the equilibrium is to change the temperature, and this applies if we have changing the temperature affects different reactions differently, depending on whether they are endo or exothermic. So you can kind of think about heat as a reactant or a product, and if a reaction is exothermic, the heat is a product, so reactant yields products plus heat. And then of course the opposite is true if it's endothermic, reactants plus heat yields products. So you really have to know the enthalpy of the reaction. One way you're told that, right, you might be given the sign for the enthalpy. If the enthalpy is positive, that is endothermic. If the enthalpy is negative, that is exothermic. So you're going to want to look for that as well. And remember that increasing the temperature, what you're doing is you're adding heat, you're adding energy. Removing heat by decreasing the temperature, of course, is removing energy from the system. So we can add or remove any reactant or product. Easy to do, just take some more reactant and throw it into the test tube. Removing a reactant or product is a little more difficult. So there are a few ways to remove a reactant or product. If it's a gas, you can just evacuate it. As it's formed, you can just let that gas go out of the reaction container. Removing a reactant or product could also mean that you're going to precipitate it out. So particularly if you have a reaction that's occurring in solution, you have all these ions floating around, you can add something that's going to react with one of those ions to form a precipitate, and that will in effect remove the reactant or the product ion that is precipitating. You can add a common ion. meaning that if you have a reaction that occurs in solution and you have these ions, you add another dissolved compound that contains an ion. You can change the pressure, and you guys, changing the pressure has to do with moles of gases. So you can kind of think of pressure as a reactant or product as well. So in the reactants, if you have like 5 moles of gas, and in the products there's only 2 moles of gas, you can think to yourself that pressure is a reactant. Typically, we alter pressure by changing the volume. So whenever you see changes in volume, what you're really going to consider there are changes in pressure. And if you remember from your gas relationships unit, if we increase the volume, that causes a decrease in pressure, and the reaction will shift in a way to undo what we did. I only include this adding an inert gas because it does not have any change at all. It causes no change, and sometimes students think, oh, well, we've added another gas. What we've really done is increase the pressure. But remember that adding more gas is going to increase pressure to the entire system, so it's not going to cause a change in the equilibrium position. So let's consider this reaction here, the production of ammonia. We can see that in this reaction there are 92 kilojoules of heat produced. This is exothermic. Another way of saying that it's exothermic is that the change in enthalpy is negative. And what we have are 3 moles plus 1 mole of gas on the reactants. So we have 4 gaseous moles in the reactants. And in the products, we only have 2 gaseous moles. So you can kind of think of pressure as being a reactant here. And here's the thing. According to LeChatelier, whatever we do to the reaction, it's going to undo it. So if we go back to our changes, if we increase the heat by increasing the temperature, the reaction is going to decrease the heat. If we remove a reactant, the reaction's going to make more reactants. If we remove a product, the reaction will shift to the right to make more products. If we add a product, the reaction will shift to the left to make more reactants. So whatever we do, it does the opposite of that. If we increase the pressure, the reaction will run to decrease the pressure. If we add a common ion, the reaction will run to get rid of that common ion. So whichever side of the reaction that's on, the reaction will shift to the opposite side. So in this reaction here for the production of ammonia, which way does the equilibrium shift if we heat the reaction vessel? So we can see that heat is a product here. It's an exothermic reaction. So what we did, we added a product. The reaction will do the opposite. The action will remove the product. The product happens to be heat. And the way it's going to shift to do that is it's going to shift to the left. Because in making more reactants, it's using up some of the heat that we've added. If it were to make more products, it would be making more heat, but it wants to make less heat. So it's going to make more reactants, and it does that by shifting to the left. If we increase the pressure, reaction will do the opposite, so it will decrease the pressure, which means that it's going to make fewer moles of gas. So what we're going to do is look at our reaction and see, well, which side has fewer moles of gas? And we can see that the reactants has 4 moles of gas, and the products have 2 moles of gas. So in order to decrease the pressure here, the reaction is going to shift to the product side because there's less gas there. So it's going to shift right. If we remove the ammonia, so we remove the ammonia, the reaction will make more ammonia, which means the reaction is going to run in the forward direction, and that we call that a shift right. If we add extra hydrogen, we added a reactant. According to LeChatelier, the reaction will do the opposite. The opposite of adding a reactant is making a product. And in order to make more products, the reaction has to run in the forward direction. That is what we call a shift right. Now, whenever we see volume, we have to think in terms of pressure. So, if we decrease the volume, what we have really done is increase the pressure. The reaction will do the opposite, and the opposite of increasing the pressure is decreasing the pressure. So if we look at the reaction, it's going to do that by making less moles of gas. If we look at our reaction, we have 4 moles of gas in the reactants, only 2 moles of gas in the product. So it's going to run in the forward direction to make fewer moles of gas, and we call that a shift to the right, in the forward direction. Okay, that is LeChatelier's principle in a nutshell.